Now let's continue our lesson by solving the example on the board. In the example given, the question says, in the diagram, the line TS is a tangent. So we could see that TS is a tangent which is touching the circumference of the circle at S. So TS is a tangent to the circle at S. If O is the center of the circle, so we have a point here O, which is the center of the circle. And then angle TSP is 21 degrees. And angle RQP is also 100 degrees. Find with reasons the angle SPR, and then the angle QSR, which is this angle. Very good. So normally when you are given a circle theorem question and you are about to answer it, what the first thing you should do is you should always apply the theorem to whatever you are going to write. So without the theorem, it becomes wrong. You can't just watch it and just look at it and say, if this is 21, this is 21, then you write 21 degrees. No, you need to write the theorem to support it. So that is the best way of getting your full mark when it comes to what? An exams, especially in section B. So in this case, we are going to assume that the angle PST, okay, which is the chord PS, meeting the tangent at ST, which is this angle 21. Now we learned that the angle between a chord and a tangent, the angle between a chord and then a tangent at the end of the chord is equal to the angle the chord makes with the circumference of the circle. Now with that in mind, we have also learned that the angle subtended by a chord to the center of a circle is twice the angle it subtends to the circumference of the circle. We also learned that the angle subtended by a diameter to the circumference of a circle is always 90 degrees. Also, we learned that angles subtended by the same chord are also what? Equal. And then the sum of opposite angles in the cyclic quadrilateral sum up to 180 degrees. So with that in mind, let's solve the question on the board. Now, the first thing that comes into mind, we have so many theorems coming into play here. So you can choose to pick whichever one you feel like starting with. Now, I want to start with the tangent and then the chord. Now we do realize that the angle between the end of this chord and this tangent, which is this angle 21 degrees, is equal to the angle this chord subtends at the circumference of the circle. So we have the chord here subtending this angle at the circumference and also this angle at the circumference. So if this angle is 21, it means the angle SRP is also what? 21 degrees. So let me use my red ink to write the answer for that one. So this is equal to 21 degrees. So we can say that the angle between a chord and a tangent at the end of the chord is equal to the angle the chord subtends at the circumference of a circle. So the angle between a chord and a tangent, which is this angle, is equal to the angle this chord subtends at the circumference. So if this angle is 21, this angle is also 21. So angle SRP, so therefore we can say that angle SRP is also equal to 21 degrees. Angle SRP is 21 because this is the chord which subtends this angle. Now, we also learned that angles subtended by the same chord are equal. Angles subtended by the same chord are equal. Now, we do realize that if SP is a chord, okay, if SP is a chord, SP subtends this angle 21 and also subtends this angle. So it means that SQP is also equal to SRP. So we can say that angle SQP is equal to angle SRP. Angle SRP. So if SRP is 21, therefore angle SQP is also 21 degrees. So if angle SQP is 21, okay, SQP is 21 degrees, and the whole of this angle RQP is a combination of angle RQS plus angle SQP. Then we say these two angles sum up to 100 degrees. It's already there that this angle is 100. And we know this angle as what? 21 degrees. So this is also 21 degrees, which is the angle SQP. SQP. So we can find the rest of this angle. Okay? So to get the rest of this angle, we are going to say that angle RQS plus angle SQP is equal to 100 degrees. Okay? And we already know SQP to be 21. So let's find the angle RQS. So we can find angle RQS plus SQP is what? 21 is equal to 100 degrees. So angle RQS is equal to 100 degrees minus 21 degrees. So therefore RQS is equal to 100 minus 21 will give us 79 degrees. So angle RQS is also equal to 79 degrees. So we have 79 degrees here, giving us, so if we should add the 79 and 21, we get a complete angle of what? 100. Now let's move on. Now the next thing we are going to do is, we also know that the angle subtended by a diameter. Now SQ, the line SQ is a diameter with center O. So remember RP is not a diameter because there's no center there. But SQ is a diameter because there's a center here. And we know that the angle subtended by a diameter to the circumference of a circle is 90 degrees. So if this is a diameter and the diameter subtends this angle at the circumference, it means that this angle here is 90. So we could say that from SRQ, the angle SRQ is equal to 90 degrees. So we can say that the angle SRQ is equal to 90 degrees. Angle SRQ is equal to 90 degrees. Why? Because the angle subtended by a diameter, the diameter is even SOQ, okay, to the circumference of a circle is 90 degrees. So if this angle is 90, okay, if this angle is 90 and we have 21 here, then we can find the rest of this angle, okay? So we can say that the whole complete angle of R is 90, and we know SRP to be equal to 21. So let's find PRQ. So PRQ plus SRP is equal to the whole angle SRQ. So we can say that the angle SRP plus angle PRQ. Angle PRQ is equal to 90 degrees. From this theorem, we know which is equal to angle SRP, okay, which is our 90. So we can find the angle PRQ. So we know SRP to be 21, so 21 degrees plus angle PRQ to be equal to 90 degrees. So angle PRQ is equal to 90 degrees minus 21 degrees. So therefore, angle PRQ is equal to, so we have 90 minus 21 to be equal to 69. So we have 69 degrees. So we have angle PRQ to be equal to 69 degrees. So now, going back to the question, at least we found some nice and some good angles in there. So we know this to be 79, this to be 21, this to be 21, this to be 69. Very good. So now, angles subtended by the same chord are equal. Angles subtended by the same chord are equal. So if this is 21, if SP is a chord, it subtends an angle 21 and also subtends this angle 21. If PQ is a chord, PQ is a chord, it subtends an angle 69 and also this angle here. It means this angle is also 69. Okay? Now, if QR is also a chord, QR is a chord, and then QR subtends this angle, it means this angle is also equal to this angle because it's coming from the same QR. And if this RS is also a chord, it subtends this angle 79 and this angle. So this angle is also 79. So let's use that in mind and then complete the whole angles of this diagram. So angles subtended by the same chord are equal. Let me have that in mind. Angles subtended by the same chord are equal. So having that in mind, we can say that angle SQP is equal to SRP, which we've done already. SQP is equal to SRP, we've done that already, is here. And we can also say that if PQ is a chord, then PRQ, angle PRQ is equal to angle PRQ, which is coming from this chord, is also equal to this angle QSP. So therefore, angle QSP is equal to what? So we said PRQ, which is 69, which is coming from this chord, 69 is also equal to this chord. So this is also 69. So this is equal to what? 69 degrees. So with that in mind, let's continue. So we traced this as a chord. We've also traced this as a chord. So now let's trace this as a chord. So there's nothing coming out here. So let's move to the next one, which is this chord, the chord RS. Okay. Now, if this is called the chord RS, RS subtends this angle 79 and also subtends this angle. So RQS is also equal to 79. Angle RQS is equal to RQS is also equal to RPS. RPS, angle RPS. So therefore, angle RPS is also equal to angle RPS. RPS is also equal to what? 79. If this is 79, this is 79. So 79 degrees. Now, so RPS is giving us 79 degrees. So therefore, angle RPS is equal to 79, which answers our first question of find with reasons the angle SPR. So the angle SPR is equal to 79 degrees. So therefore, angle SPR is equal to 79 degrees, which answers the first part. Now, moving on to the second part of the question, where we are asked to solve for angle QSR, which is this angle. Now, we know this angle to be 100 degrees, and we know that the sum of opposite angles in a cyclic quadrilateral sum up to 180. Now, from this, we could say that PQRS is a cyclic quadrilateral. Why? Because the vertices of the quadrilateral PQRS are touching what? The circumference of the circle. Okay? So, if the sum of opposite angles in a cyclic quadrilateral sum up to 180, and the whole of this angle, 79 plus 21 is 100, and then this angle is what? So sum of opposite angles should sum up to 180. So if this is 100, this angle should be 80. And this is already 69. So if we should subtract it from 80, we'll get the smaller angle, which will give us the angle QSR. I hope you understand. What I'm trying to say is the sum of opposite angles in the cyclic quadrilateral. So this angle, the whole of this angle, plus the whole of this angle should sum up to 180. Since this PQRS is a cyclic quadrilateral. So let me continue here. Pardon me, but since PQRS is a cyclic quadrilateral, we can say that angle RQS or angle RQP plus angle RSP should be equal to 180. So we can say that sum of opposite angles in a cyclic quadrilateral add up to 180 degrees. So the sum of opposite angles in here, so which is the included angle here and this included angle, add up to 180. So we can say 100 plus, so 100 plus, let's name this W, okay? So the whole of this angle, which is angle RSP is 69 plus W. So 69 plus W is equal to 180 degrees, okay? And we know our W is what? The angle RSQ, okay? So we can say let W be equal to angle RSP. So the sum of opposite angles sum up to what? 180. So this will give us 169 plus W is equal to 180. W will be equal to 180 minus 169 degrees. So our W will finally be equal to 11 degrees. So W is equal to 11 degrees. So if W is equal to 11, it means that therefore our angle QSR is equal to what? 11 degrees. So you could see that in this question, we made use of the angle subtended by a diameter to the circumference of a circle, meaning SOQ is a diameter. So we made use of that theorem. Then we made use of SP being a chord subtending two angles being equal. PQ also being a chord subtending two angles being equal. QR also being a chord subtending these two angles being equal. And then RS being a chord subtending these angles being equal. So you could see from here that if W is 21 degrees, it means that if this is a chord and this subtends 21, then this angle is also what? 21 degrees. Okay, so this is how we go about solving questions under circle theory. We shall continue with the other theorems. If you have any question, you could go to the administrator and then you get back to me, and I'm sure I'll be around to answer you. Thank you so much.